Jenny has invited Amanda over to her house for lunch. Amanda says she is thirsty and would like something to drink. Jenny comes back with a glass of milk and hands it to Amanda. Amanda takes a big sip of the milk and swallows it. Almost immediately, Amanda feels like there is something wrong. She has a strong urge to use the restroom. Amanda excuses herself and hurries to the restroom. Amanda is washing her hands in the sink after doing her business and sees she is pale and sweating and has developed painful cramps in her abdomen. Amanda has no idea what could be happening, but it can all be figured out by having a look inside her digestive tract. Amanda's gastrointestinal tract contains her stomach, small intestine, large intestine, among other organs. The source of the problem is coming from her small intestine, so let's take a closer look. Along the walls of her intestine are microvilli, which aid the body in absorbing nutrients. Within Amanda's small intestine, we can see the enzyme lactase. Lactase is found in the bush border of the small intestine, which is made up of microvilli. The lactase enzyme aids in breaking down the sugars in dairy products, specifically from lactose. Let's have a look at how this process works. Lactose has an active site, more specifically a beta-galactosidase site, because it is a galactosidase enzyme, which specifically targets disaccharides that have a galactose beta link in between. The active site has two distinct subsites. One subsite is for galactose because it has a high selectivity. The other subsite allows for versatile binding. The oxygen within lactose is in the upright position or beta position, making this the perfect combination. Acidic glutamate acid residue donates a proton to the glycosidic oxygen on lactose, which weakens the bond. The now basic glutamate residue interacts with water, obtaining a proton. This turns it into a hydroxide ion. The new hydroxide ion attacks the electrophilic carbon on the glucose component, which completely breaks the bond, resulting in the product formation of glucose and galactose. Lactase is a beta-galactosidase enzyme, which means it perfectly catalyzes the hydrolysis of the glycosidic bond that is in lactose, aiding in the breakdown of lactose into galactose and glucose, which can then be metabolized in your body. Lactase concentration is highest in infancy, and as humans age, the lactase levels drop drastically, which can cause lactose intolerance in adults, meaning the lactose is not being fully metabolized by the body. There aren't enough lactase enzymes able to bind the lactose through their active site. The lack of lactase causes lactose to build up within the small intestine. Because of its accumulation, lactose can be grabbed by bacteria in the intestine. Some bacteria are able to metabolize lactose into certain gases. This can lead to a buildup of gases like carbon dioxide, hydrogen gas, or even methane within the small intestine. This is likely the cause of Amanda's painful stomach. If lactose levels in the small intestine accumulate astronomically, then the small intestine develops a high solute concentration. This means the lactose concentration is so high that it has created a high osmolarity within the small intestine. The reaction to this problem is for water from the outside areas to osmose into the small intestine to balance it. With a large accumulation of water in the small intestine, this leads to lactose-intolerant people having extremely watery stool, which is unfortunately another symptom Amanda is suffering from. Jenny realized that Amanda was having a reaction to her milk, so the next time she came over, she had a surprise for her. Jenny provided Amanda with her very own lactose-free milk so they can both enjoy it with the cookies that were baking in her oven.